Previously seen how we can use the molar ratio of a balanced chemical equation to work out the proportion in which moles of different substances will react during a reaction. Now, to begin with, any of these types of problems, we need a balanced chemical equation. To be honest with you, the Leaving Cert chemistry paper always gives you a balanced chemical equation for these types of questions, but it's still a good skill for you to be able to do. So what I want you to do is pause the video, write this down, and have a go at balancing it. All right, to balance this successfully, I would start with the oxygens. Here I've got one oxygen on the right and I've got two on the left. So to balance that out, I'm going to make a 2 of this whole thing on the right. Okay, so now I've got 2 oxygens here. I've created another problem though. I've now got 2 times 2 lithiums, which is 4 lithiums. And I've only got 1 on the left here. So to balance that out, I'm going to put a 4 on the left here. And we know here that these things on the left here, these are called reactants, sometimes also called reagents. These are the things we begin with. And this thing on the right here, this is our product. Now, our molar ratio tells us, and we can write it down below here just for simple sake. Our molar ratio tells us the ratio in which things react in. So 4 moles of lithium react with 1 mole of oxygen to give us 2 moles of lithium oxide. Now, some of the previous examples, we would have looked at, well, how do we work out if we started with a number of moles of, say, lithium moles? Let's just say we started with 10 moles of lithium. I'm not going to go through the whole process, but when we convert to find out how many moles of oxygen we need, we would figure out that we need 2.5 moles of oxygen to make 5 moles of the lithium oxide. Again, if you don't know how to do that, and I suggest you go and watch some of the previous videos first where we did that there. Now, in theory, this is fine. 10 moles, we need to put in exactly 10 moles of lithium and put in exactly 2.5 moles of oxygen, and we'll get exactly 5 moles of lithium oxide. That's not really that's not reality. In theory, that's fine, but it's not really reality. In reality, we never measure exactly 10 moles, exactly 2.5 moles of oxygen. It's just not practical. Usually we put in a rough amount and we let them react and we see what happens. So let's just say instead of 2.5 moles of oxygen, we did put in 10 moles of lithium. We put in exactly 10 moles of lithium, but instead of 2.5 moles, we put in a little bit extra. So we put in 2.8 moles. And this is more along the lines of what would really happen in a real life example. You might put in an exact amount of something, you put in a rough amount of something else. You're not really putting in exact amounts when you do a chemical reaction. But what we can see here is that the oxygen, we have more than we need. Because if we started with 10 moles of lithium, we only needed 2.5 moles of the oxygen. So we have more than enough of the oxygen here. So we can say, I'm going to put a circle around this and we say this one here, we have more than we need. More than we need. And what this means is that at the end, you will have some oxygen left over. It will not react. There will be some left over. Okay, so we will react in full 10 moles of the lithium with the 2.5 moles of the oxygen. We will make 5 moles of the lithium oxide, and we will have 0.3 moles of the oxygen left over, this little bit extra. In this case, we say that oxygen is what we call, it's in excess. It's the excess reagent or the excess reactant. There's more than we need to complete the reaction. Now, if we look at the other example, in this case, the oxygen here, all of this has reacted. This will all be reacted because there's more than enough of the other one. So this will all have reacted, all 10 moles. There will be none left over. And it's the fact that this has run out that has stopped the reaction. If there was more of this, it could have kept reacting with the oxygen. So it's this that has limited the reaction to stop when it did. So we can't make any more product because we ran out of lithium. This was the limiting reactant. So we call this a limiting reactant. So there's 2 new terminologies. We've got the limiting reactant and we've got the excess reactant. The excess is the one you have more than enough of, more moles than you required. And the limiting one is the one where you had the lower number of moles, if you like. So if you compare 2 things, the one that you had more moles of, that's the excess. The one that you have less moles of than you need it according to the equation, that's going to be the limiting reagent. So let's just say we had a little example We'll do one here. Sorry, I'll just write it out here. Let's say we had 3 moles of magnesium reacts with 7 moles of oxygen, O2, which is the limiting reagent. So in a question like this, limiting reactant. In a question like this, how do we go about answering? Well, we know how many moles of magnesium we've got. We know how many moles of oxygen are reacting. The first thing we need to do is we need to write down the equation for this. So we reactant Mg plus O2 reacts to give MgO, magnesium oxide. So again, the first thing we need to do is balance this equation. Now, like I told you, in the Leaving Cert Chemistry exam papers, they always give you the balanced equation, but it's still a good idea for you to practice this now. So I want you to pause the video and have a go at this now, balance the equation. Okay, so what you should have done to balance it, well, you've got 2 oxygens here, you've only got 1 over here, so I'm going to put the 2 here to balance out the oxygens, and I've now made 2 Mgs as well, so I need to balance that by putting a second Mg over here. So next thing, on the next line, I want you to write down what's the ratio, the molar ratio here. Pause the video, write that down. Okay, so here it's 2 is to 1 is to 2. Now I'm going to take over from here and I'm going to show you how to do the rest of it. That bit should have been easy. So it says we reacted 3 moles of magnesium with 7 moles of O2. Now I'm going to pick one of these and I'm going to find out which one is the limiting reagent. I'm going to do this by picking either magnesium or oxygen. I'm going to go with the magnesium. I'm going to start with 3 moles of magnesium and find out how many moles in a theoretical situation would I need to react with that. So the way I do this is I write my moles down here. I put my target. I want to get to 3. Okay, so we showed you how to do this before. You take your 2, you divide by that first target number, divide by 2 to make this a 1. And then you take that 1 and you turn it into a 3 by multiplying it by 3. Okay, so you multiply by the second target number. So you take your ratio, divide by the target, first target, then multiply by the second target. Again, if that doesn't make sense, go back and watch the previous videos. Now what we've got to do is do the same to the oxygen to find out how many moles of the oxygen would I need here. So divide by 2, that's going to give me 0.5. And then times by 3, that's going to give me 1.5. So it says here that in theory, I would need 3 moles of magnesium and I would only need 1.5 moles of oxygen to react with that. Well, it clearly says here that I had 7 moles of oxygen. So I had 7 moles of this. This is what I had. So I obviously had more than enough. Okay, so 3 moles of magnesium requires 1.5 moles of oxygen. And then just clarify which one is limiting and which one is excess. The question asked for the limiting reactant, so make sure you do that one. I'm going to say that it's actually the magnesium then that's a limiting reactant. We have way more than we need of the oxygen, so it's the magnesium that's limiting. So magnesium is limiting, or you could say the limiting reactant. And what does that mean about the oxygen? O2 is in excess. Right, so that's how you do that, guys. If you want to pause the video, take down that example. And now I have one for you to do. Now I've balanced this equation for you already. Okay, what I want you to do is take over from here and figure out what is the limiting reactant. So some of you should be able to do this straight, flat out from here. Do it by yourselves. Pause the video and have a go at that now. All right, so if you didn't know how to get started, we'll help you lay it out. The first thing you want to do is write down your ratio. Okay, so underneath, do that now. Then you want to write down your target line, your moles, and you want to choose one of the reactants, and you want to make that your target and work out how many moles of the other thing would you need to react with that. So if you weren't able to start this, pause the video, have a go at this now. All right, so the first thing you want to do is you want to have a look at the ratio. It's 2 is to 6 is to 2 is to 3. And we're dealing with the reactants here. Okay, so we want to know what the molar ratio of the reactants is 2 ALs to 6 HCls. Now, I'm just going to start with this one because it's simplest, maybe. We've got 2 moles of aluminium at the start, sorry, 4 moles of aluminium at the start. So here I'm going to find out for 4 moles of aluminium, how much HCl would I need? So I take my ratio and I divide by my first target, which is 2. So turn this into a 1 basically. So divide 2 by 2, that makes it a 1. And take your 1, and how can I turn it into a 4? Well, I multiply it by the second target, which is 4. I'll multiply it by 4, and I'm going to do the same to this side. Divide by 2, and then times it by 4. Okay, so 3 times by 4 is 12. Okay, so for 4 moles of aluminium, I would need 12 moles of HCl. Now in red, what do I actually have? I have only 3 moles of HCl. So I only actually had 3 moles of HCl, so I don't have enough. That means I have way more than I need of the aluminium, and I have nowhere near enough of the HCl. So clarify this with a sentence. 4 moles of Al requires 12 moles of HCl. So in the next line, clarify, sentence, bullet point, which one is the limiting reagent? Pause the video, write it down now. Okay, so you should have written that HCl is the limiting reactant. Well done, if you got that right, super stuff. Okay, obviously it's also true then that Al is in excess, or it's the excess reactant. Okay, I have a couple for you to practice now. Right, so going to go back over here, and we are going to show you, where are we? Okay, yeah, so let's have a look at question 37 and question 38. Okay, there's a couple of challenge ones in there that some of you definitely will be able to do, hopefully be able to do, but for most of us, I think we should be able to do everything there. Maybe C might be a challenge for a couple of you, but most of us should be able to do it all. So we're going to pause the video, have a look at them questions now. All right, so we go through the answers to them the next day in class. We're just going to now take a look at how this can become a little bit more complicated. This can become a little bit more complicated when they don't give you moles in the beginning. They give you reactant masses, and they ask you to find out which one is in excess and which one is limiting. Okay, so let's say, for example, that we are given this problem. 5 grams of iron reacts with 5 grams of sulfur. It says show that iron is limiting. Now, we know that the first thing we've got to do is balance the equation. Take a look there and see, does it need balancing? You should hopefully see that it doesn't need balancing, it's already balanced. So we're going to go ahead and write down the ratio underneath. So you can pause the video. I suggest you write down the question as an example, and you take down the equation and you write down the ratio then. So pause the video and take your time and do that. All right, hopefully you've seen that the ratio here is a 1 is to 1 is to 1 is to 1. Okay, 1 is to 1 is to 1. Now this here, remember, it's called the molar ratio. This tells us about how the moles of the substances react, which means it only applies to moles. So we cannot put grams in here. We must convert them to moles first of all. That's the only extra step here, is turning the grams of stuff into moles of stuff before we put it in the equation. So I'm going to show you how to do that. Out at the side here is a bit of rough work. I've got 5 grams of iron, Fe, and I've got 5 grams of sulfur, S. So what I have to do is convert to moles of each, moles and moles. Now I know my formula is moles equals mass divided by mol. Again, nothing new there, done it loads of times. So my moles of each substance, I have to take my mass, which is 5 grams. Iron has a molecular mass of 56. And then for sulfur, it's 5 grams and the molecular mass is 32. So I'm going to go ahead and work out the moles here. That gives me 0.089 moles of iron, and I'm going to get 0.156 grams of sulfur. Okay, so sorry, moles of sulfur. So now I have moles of iron and moles of sulfur. So the next thing then is to choose one of these and put it into our moles line and see how many moles of the other thing that would require. So here I'm just going to go with iron because it's the one at the top. I'm going to say, okay, if my target is 0.089 moles of iron, how do I do that? I take my 1, I divide by my first target, which is a 1 in this case. That makes it a 1. and then I times it by the second target, which is this one, 0.089. Now, hopefully you can see, so 1:1 ratio. So when we do the same things over here, we're going to get the same number of moles, 0.089. So underneath, let's just clarify, 0.089 moles of Fe requires 0.089 moles of S. Okay, so that's the first thing I'm noticing. And then I'm looking at my numbers. Well, I actually have way more than that of the S. So therefore, S is in excess and iron is limiting, which is what it said we should be able to show. Show that iron is limiting. So Fe is limiting, because we've got way more sulfur. You could say that either. You could say we have 0.156 grams of S, so Fe is limiting. All right, so that's the only bit really that makes this any harder. So I've got some more for you to practice now, working with masses. So let's have a look at this. We've done 39 there, so that one's done there as your example. If you want, you can go back and take it down if you want as an example. And then the next two for you guys should be easy enough. Let's try 40 and... Okay, so this one is a bit of a challenge. Okay, it says, what mass of carbon dioxide would you expect to obtain from the reaction? Remember to use the limiting number of moles as your limiting reactant. So when you're working this out, you've got to use the limiting reactant, because that's going to stop the progression of the reaction. So whichever one is limiting, that's the number of moles you have to put as your target. Okay, so be careful with that one. Definitely a bit of a challenge there. And what about the next one? Again, the same idea. Don't forget to use the limiting reactant, the limiting number of moles, as your target in this reaction, okay, for the challenge. But part A here and part C here, everyone should be able to do. The challenge then, you do need to be able to do this on the Lehman search, so definitely work practicing these now. And if you can do them by yourself today, then brilliant. All right, that's it, guys. We'll go through them the next day in class, and hopefully you have built up a bit of confidence there in those. So if you found this video helpful, do give it a like, and we'll see you the next day in class.